So what we've talked about so far is how to integrate an expression with respect to a variable. Now, when we anti-differentiate from last time, we'll end up with the anti-differentiated expression plus c. And that's what you get when your integration sign is alone. But what happens when we encounter something like, let's say we got a at the bottom here, the b at the top here. So two different numbers, a and b. So what this is really saying is I need to anti-diff from x is equal to a to x is equal to b. So to put this into a little bit of context, let's say that we start with our gradient function, and when we anti-diff, of course, we end up with the original. So we have f of x. And what happens over here? Well, we don't have the plus c anymore. So normally with our indefinite integrals, this is what happens. But when there's terminals over here, you don't need your c values anymore. So just make a note that if you have a definite integral, there's no c constant. Okay, but instead, what happens is you need to use these two numbers over here. And what we're going to be doing there is we're going to be subbing in b and subbing in a. And when to sub them in? Well, top one goes first, and bottom one goes second. So what you need to do with the first one is sub it in, of course, and subbing in b into here, x is equal to b, will give you f of b. And you want to subtract by subbing in x equals to a, so we get f of a. And this would be the general form of the definite integral of this one over here. Okay, so let's put this into more context by doing a few examples together. Down over here. So if you ever feel like you want to give it a go yourself, just pause the video and attempt it yourself. So for the first one here, now the integral between x equals to 1 to 2, and first of all, we need to find out the integral of the expression here. So x cubed will turn to x to the power of 4 over 4 minus this 2x over here, so that means we get 2x squared divided by 2, and we keep our terminals on the outside of these square brackets. So before we keep going, we can say that these two can cancel out, so we just get minus x squared. So what you want to do here first is sub in x is equal to 2. You sub in x is equal to 2, then this means, well, actually, let's do 3 different colors. So for x equals to 2, get 16 on 4 minus 2 squared. So we get 4 over here. And in the second case, we want to sub in x is equal to 1, but we want to subtract by the result of this. So 1 to the power of 4 over 4, 1/4, and minus 1 squared, which is 1. Okay, so taking all that into account, we can just evaluate from here. So what we're going to get over here is, well, this turns into 4. So we actually get 0 over here. And what we're left with is actually negative of minus 3/4. So this means our result over here would just be 3 on 4. So your definite integral will work out to be some sort of constant. Okay, so in this next one over here, we want to integrate from 0 to pi on 3 of this expression. So when we do this, remember that you can chuck this constant over here right to the outside. And so this would end up being the integral of 0 to pi on 3 sine x on 2 dx. Okay, so when you want to integrate sine, well, sine goes back into cos, and it's negative cos. So putting the 3 on the outside, we're dealing with that later. So we're going to get negative cos x on 2. Yeah, I'll just scroll over a little bit. And the coefficient of x here is half, so we need to say 1 divided by half over here. Okay, and our terminals are 0 and pi on 3. Well, this part over here is -2. So if this is -2, then you can actually chuck this -2 to the outside. So just remember that when you're in your square bracket phase of your definite integral, you can still take the any constant coefficients out to the front. So that's what we're going to be doing before we keep going. So we have -6 at the front, and what we're really doing is we can sub our terminals into simply just x onto, sorry, not x onto. Yeah, it is x onto, I miswrote. Cos of x onto, pi on 2, and 0. Okay. So let's chuck these numbers in. Keeping the 6 at the front. First of all, we're going to get cos. Yeah, we'll do that. Cos of pi on 2 divided by 2 is pi on 4. Now chucking in the 0, so we're going to be subtracting by cos of 0 on 2, which is 0. This will give us, let's see, cos of pi on 4 is in the first quadrant, so we're going to get positive root 2 on 2. Cos of 0 is 1. So our end result here is, well, you can leave it like this if you want, but I'm just going to get rid of the negative sign here and any denominators that we have. So this part, just consider this as optional. We do have an exact answer here, but just to make things a little bit clearer, I'm going to say that we have positive 3 and multiply everything inside by -2, so that we're going to end up with 2 minus root 2. Okay, and that would be our constant, which is equal to our definite integral from up over here.